Hi everyone, Mr. Kuchenmeister here, and welcome on into section 3.4 for geometry, where we're going to be talking about perpendicular lines, and our goal is to prove and use theorems about perpendicular lines. So let's go ahead and get started here. All right, so we're going to start off with some vocabulary, all right? So the perpendicular bisector is a line that is perpendicular to a segment at its midpoint. In other words, it does exactly what is in the word perpendicular bisector. Right, so if I were to highlight this, right, so we have a perpendicular bisector. It's a bisector that is perpendicular to a segment, and it bisects it at its midpoint, okay? So a couple of things here. First caveat, right? Just a friendly reminder that in geometry, when we bisect something, the thing doing the bisecting can be a segment, a ray, or a line. So you see how here we have line here? This line really could be, it could also be it could be a ray, or it could be a line segment, okay? It's not just having to be a line. However, okay, the thing being bisected can only be a segment. So this has to remain a segment. And remember, we talked about you can't cut a ray or a line in half. All right. So here's a perfect drawing here. If I come down, let me get rid of this now. So you see here the vertical line and a horizontal line here. This is an example of a perpendicular bisector. This is the perpendicular bisector. So I have it drawn in as a ray, but friendly reminder, like I could change my mind. I can make this arrow at midpoint and now it's a segment. Or what I could do is I could extend both ways and have this be a line. This can be whatever it wants. However, the thing being bisected has to be a segment. How do you know it's a perpendicular bisector? You'll see two things. You'll see a right angle mark right here. That means 90. That's the definition of perpendicular. Two things intersecting at a 90-degree angle. How do you know it's being bisected? Well, we know the tick mark. So that means this line segment is congruent to this line segment. All right. So a cool fact about this, right, is what we can do with perpendicular bisectors is that they can be we can use this to find the shortest distance between a line and a point. So if I'm looking at this, right, we know from early on in geometry here that the shortest distance between 2 points will always be a straight line, right? That's just like one of the very first postulates we discussed in this class, okay? But what about the shortest distance between a point and a line? So from here, I want you to kind of think about this. What is going to be the shortest distance from these points to the line? And the answer is actually the perpendicular bisector. So a basic fact here about perpendicular segments is shortest distance is all from a point to a line will always be the perpendicular segment from the point to the line. So from here, right, let's just say here, like I add some points into this drawing here. Maybe I put one here, maybe I put one here, and now instead of one segment, I have two. Ooh, that was very crappily drawn. Okay, sorry guys, it's late. This is my second time making the video because the audio didn't record, but it's fine. Everything is fine. Okay, so I have three segments here. I'll just call them 1, 2, and 3. Which one do you think is going to be the shortest? Well, and the answer we discovered is it will always be segment number 2 here. So what can I do here? Let's do some practice problems. Okay, example 1. Okay, shortest segment from point P to line AC. All right, so if I look here, here's point P right here. All right, I have 3 different points on line AC. I have point A, I have point D, and I have point B. So the 3 possible segments I have is segment PA, segment PB, and segment PC. One with the shortest distance will always be the perpendicular one. So that is going to be segment PB. Now, what can I do here is I can actually set up an inequality here to solve for x. Okay, because I am told that the length of segment PA is x plus 3, and I'm told that the length of segment PB is equal to 5. And what can I do to solve for x here? Well, I know they're not equal, all right? But what we can do is we can use the fact that the shortest distance is the perpendicular segment to our advantage here. So remember, inequality means one of these signs, less than, greater than, less than or equal to, greater than or equal to. And what we're going to do here is we're going to set this up so that it is always the shorter side is less than the longer side. And if I look here, since this will always be the shortest, this is my short, and then this is my long. So this is going to be segment PB, or the length is less than segment PA, or I can write it as x plus 3. Oh, wrong way. I can write it as 5 is less than x plus 3, and I can solve for x by subtracting 3 from both sides. So 2 is less than x, or I can write this as x is greater than 2. Either or works out. Try it out on this one. Pause the video and try this now. All right, so the shortest length is going to be our perpendicular segment AB. So that means we're going to have shorter is less than long, which means the length of AB is going to be less than the length of AC. So x minus 5 is less than 12. So we got add 5 to both sides, and I get x is less than 17. Very good. All right, moving right on along here. All right. All right, here are your main theorems here. Okay, we're not really going to do the proofs, but we're just going to use these theorems to solve some problems here. So starting off, right, we have the first theorem. I will tell you the most important one is going to be the second one, and that's why this one has a name. All right. If two intersecting lines form a linear pair of congruent angles, then the lines are perpendicular. All right, so that's saying is, hey, if you have a situation like this, where these two angles, which form a linear pair, because once again here, I have two angles that are adjacent and opposite rays form a straight angle. Okay, so if these two are congruent, all right, then we can say these two lines are perpendicular. And the reasons being is, we know linear pairs are supplementary, so the only way I can have supplementary angles that are congruent is if both of these are 90. And that would mean we have perpendicular. All right, the perpendicular transversal theorem. In a plane, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. What this is saying is, here you have two parallel lines, N and P. You have a transversal Q. What this says, if Q is perpendicular to N, so by the right angle mark, then we can also say Q is perpendicular to P and write this, okay? Think corresponding angles here, right? If this is 90, that's got to be 90. And lastly, this last one is, if two coplanar lines are perpendicular to the same line, then the two lines are parallel to each other. So again, if you have two lines, not sure if they're parallel, but you have perpendicular here, or 90-degree angles, well, then we can use converse to alternate to corresponding angles postulate and say these are parallel. All right, a little bit of a break from proofs in this section, but we are going to solve some problems here. Okay, so going off here, okay, solve to find x and y in each diagram here. All right, so what we're going to do is we're going to use some of these new theorems, we're going to use some of the old theorems we've learned, and then we're just going to have at it here, all right? So, starting off here, okay? I have two parallel lines by a transversal, all right? And I have this angle right here is 3y minus 2x. This angle right here is 2x, okay? So, starting right off the bat, those two angles marked are corresponding angles. Or I'm sorry, not corresponding angles, they're alternate interior angles. So, we could go 2x equals 3y minus 2x. But the problem here is I got x and y in one equation here, so that's not really going to help my life out here. So I'm going to erase that. Okay, now what can I do? Well, this is an example of using this this perpendicular transversal theorem, because it says, hey, These two angles are perpendicular because they meet at a 90-degree angle. So that means these two lines have to meet at a 90-degree angle, and they're perpendicular. But what I can say is, hey, not only is this 90, so is this. Why does that help me? Well, now I have linear pairs here. And I can say, hey, 2x is equal to 90. And then I can divide both sides by 2 to get x is equal to 45. All right? So I know x is now 45. Now, why does that help me? Well, now I can jump down to the fact that, well, this angle also has to be 90, right? Alternate interior angles, right? So that means 3y minus 2x has to be equal to 90. I just found x, which is 45, so I can go 3y minus 2 times 45 equals 90. And then from here, just alpha. We got 3y minus 2 times 45, which is 90, equals 90. Add 90 to both sides. I have 3y equals 180. Divide both sides by 3. We get y equals 60. So y is 60, x is 45. Try this one. And I will just blast the answers here, okay? So pause the video and try this now, and then we'll get going. Okay, so the setup here will be 6y equals 90. Divide both sides by 6. Y equals 90 divided by 6, so that would be 15. And then 5x plus 4y equals 90. So we're going to get 5x plus 4 times 15 equals 90. So that's going to be 5x plus 60 equals 90. Subtract 60, 5x equals 30, and thus x equals 6. Cool. All right, these two are a little harder. Let's start with C. Okay? C, I just have two lines intersecting, right? So I know all of these angles here are going to be 90 because I have linear pairs, right? So I can write two things here. I can write 2x plus y equals 90. And then I have 10x minus 4y equals 90. And what I've done here is I've created a system of equations. So let's go ahead and solve this by elimination. All right, let's get this top y here to be positive 4y. So I'm going to multiply this whole guy by 4. That's going to give me 8x plus 4y equals 360. Then what I'm going to do is I'm just going to add these equations together. 18x, these y's cancel. 90 plus 360 is 450. And I'm going to divide both sides by 18. And I'm going to get x equals 25. Come back in. Let's solve for y. Let's do the first one. 2x plus y equals 90. So 2 times 25 plus y equals 90. We get 50 plus y equals 90. Got 50. So y equals 40. Very good. All right, this next one is a little tricky, but it combines some stuff we know. Okay, so this is going to use this last term down here. Okay, so what you notice here is I have multiple things going on here, right? I have two perpendicular lines, so what this is going to mean, we're going to use the fact here that if two coplanar lines are perpendicular to the same line, then the two lines are parallel. So guess what? See these two lines here are going parallel here? There you go. That's going to open up some things. Starting off, let's start with this angle and this angle. For alternate exterior. Alternate exterior angles are congruent. So, an alternate exterior here, right? So that's going to be x plus y equals y. And if I put this in standard form by just subtracting 2y from both sides, I have x minus y equals 0. Now let's do, how does this first right angle and this angle form? Well, that's a linear pair. So that's going to be x plus y plus x equals 180, or in other words, 2x plus y equals 180. Now I have a system. We'll move this guy over here. And I'm going to have, adding them together, I have x plus 2x, 3x. Negative y plus y cancels. 0 plus 180, 180. Divided by 3. X equals 6. All right. And then coming back in, let's do x minus y equals 60. So x minus y equals 60. 60 minus, oh, I'm sorry. I totally wrote that wrong. All right, x minus y equals 0. So we got 60 minus y equals 0. Negative y equals negative 60. So y equals 60. So both x and y here are 60. Very good. All right, that was a tricky one. Okay. Determine if there's enough information in the given diagram to prove each statement here. So here's what I got here. Be careful. Don't assume. Just like we talked about in class. So I got some angles here. All right. I have two 90-degree angles, which means since these two are perpendicular, we can say these two lines are parallel. But I can't say it's parallel to the third one. I know nothing about this line in relation. Even though it certainly looks parallel, we don't have enough information. Now, based off of that, let's do something. So, can I say angles 1 and angle 2 are congruent? Oh, and by the way, you should be doing this. You should be saying yes or no before I give you the answer, all right? So, is 1 and 2 congruent? And the answer is yeah. And the reason why, vertical angles. Vertical angles will always be congruent. You don't need parallel for that. All right, 2 and 3. Do you have enough information to say that 2 and 3 are? And the answer is no. You don't have parallel lines. We don't know that this line right here is parallel to this line. So even though 2 and 3 are corresponding, we don't know about this line, so we can't say no. 3 and 4, we can. Because you have two parallel lines here, and here, definitely corresponding. Yes, corresponding. All right. Last but not, let's go down the line here. Okay. 1 is congruent to 3. Can we say that? Again, no parallel lines. No. Even though they're alternate interior, no. 2 and 4, same reason. No. Don't know anything about this line. And lastly, 3 and 5, yes, you can. We have alternate exterior. All right. Let's move on. So, in conclusion, okay, consider the diagram. If you are given measure of 1 equals measure of 2, okay, well, then we can say line M is perpendicular to line P, because these two would have to be, since they're a linear pair, they would have to be congruent. If you're told measure of 2 and measure of 3 are 90, then we can say M is parallel to M. This is your perpendicular transversal theorem. And lastly, if you know measure of 2 is 90 and M is parallel to N, then you could say two things. Measure of 3 equals 90, as well as N being perpendicular to P. All right, that's all I got. So the homework tonight is going to be homework 3.4. Okay, there's also, ignore these days when you're watching these videos. Just next class, there'll be a quiz over 3.1 and 3.4. We do have a quiz review on 3.1 and 3.4 review, but please know it's not homework. You'll have time next class to work on it, but feel free to grab one if you want it. All right, that's all I got. We'll see you guys soon and see you guys next time in class.